Okay, we're gonna do this again. So I've drawn the diagram here, and these are the distances that we inferred from the question. This is 5 meters, this is 3 meters, this is 8 meters, and this is 4 meters, right? And we have three forces acting on the system. The first one is the tension in this ring. The second one is the weight of the boom, which we're denoting by M, the lowercase m, which is this thing. And then we have the weight of the crate, which is this thing here, and we're denoting it by capital M, right? So the first thing we're going to do is we're going to find these angles. This is theta 1, this is theta 2, and this whole thing is theta. So to find theta 1, we're simply going to use some trigonometry, and we're going to use this triangle. So this is theta 1, this is the perpendicular, and this base is 8 meters. The perpendicular is 5 meters. So theta 1 is simply going to be tan inverse of 5 over 8, the perpendicular over base, which comes out to be 32 degrees. Similarly, for theta 2, we're going to use this triangle, right? And the perpendicular is 3 meters, the base is 8 meters again, and theta 2 comes out to be this thing, 20.55 degrees. And the total theta, this thing, is the sum of theta 1 plus theta 2, and is the sum of these two things, so it's 52.55 degrees, right? So we're going to use the same principle. We know that the system is in equilibrium, right? The sum of all torques acting on it must be 0. Or we could say that the anti-clockwise torque is equal to the clockwise torque, right? So if the tension is causing the anti-clockwise torque, we can take the weights to be causing the clockwise torque. So first, let's find the anti-clockwise torque. The anti-clockwise torque is simply going to be the moment arm, which is 8 meters, right, times the sine component of the tension. The sine component of the tension is this thing here in this direction, right? This t sine of theta, the whole theta. And the cos component of the tension is going to be in this direction, right? This is the t sine theta is at 90 degrees to the boom, right? So that's our anti-clockwise torque complete. Now for the clockwise torque, we have two forces. The first one is the weight of the boom, which is this thing, mg. And to find the torque, the moment arm for this is 4 meters, since we take the weight to be acting in the center of the boom. So 4 times mg cos of theta 2. This is theta 2. This is also theta 2. These two angles are equal. So the weight, since it's acting down on an angle, is going to be mg cos of theta 2 times the moment arm, which is 4 meters. So this is the first term in our anti-clockwise torque. The second term is due to this crate. It's the same thing, the weight of the crate acting down on an angle, 8 times mg cos of theta 2. 8 is our moment arm, and rest is the force. So the sum of these torques, these two torques, is the clockwise torque, and this is the anti-clockwise torque. So in this equation, we know everything except for the tension, right? So we just plug in the values, and we isolate T, and T comes out to be this thing here, 2401.7 newtons, right? Okay.